actually from a previous lesson. These lines are perpendicular. What is the value of k? So firstly, what we want to make sure we do is we want to make sure they are in y equals mx plus b format. And the reason we want to do that is because then you can read the slope. So to do that, we need to isolate for y. And if we do that in the first equation, you're going to have y is equal to 4 over k x plus 9 over k. So that looks pretty ugly. But the other equation is this one, 5x minus 7. Now, we know that the blue line is perpendicular to the black line. So if I draw the black line, I can just kind of do a sketch here. And I can see that the slope is 5x and the y-intercept is negative 7. So I'm expecting quite a steep line, just my estimate here of what the black line would look like. And I don't know what the y-intercept of this blue line is, but I do know that it is perpendicular to this one. So maybe it looks like this, maybe it's over here, but whatever that blue line is, it is perpendicular. That means that we have a relationship with the black slope and the blue slope. So if you wanted to know the slope of the blue line, we can take the slope of the black line and we can think about what would be perpendicular to it. So if you wanted the slope of the blue line, you could say, well, it's not 5. It's in fact much shallower and it's a negative slope. You want to take the negative reciprocal of that. So the slope that we're looking for is negative 1/5. That is the blue slope, negative 1/5, because it's perpendicular to the black one. Once you know the blue slope, you can take this slope and set it equal to this slope. So 4 over k is equal to negative 1/5. Then you need to know how to solve for k. So k is in the bottom. We don't like that. So we're going to multiply both sides by k. 4 is equal to negative k over 5. I will multiply both sides by negative 5. Yeah. So that will kill the 5 and the negative. And we have negative 20 is equal to k. If they give you a point and a slope, then you can write it in slope point form. So I'm just going to label this here. This is x1. This is y1. And this, of course, is your slope m. So if I'm trying to write this in slope point form, I can say like y minus y1, which is 2, equals negative 1/3 x minus x1. So I'm subtracting a negative because x1 is negative, so I'm just going to write plus 4. So that is your equation in slope point form. Part B is asking for it in general form. This is clearly not in general form. So what we're going to do is we are going to convert it to general form. So first of all, I don't like fractions in general form. I'm going to multiply both sides by 3 to try and get rid of that fraction. Actually, let's do negative 3. So we'll multiply this side by negative 3 and this side by negative 3. So if your algebra is good, you will realize that it kills off the negative 1/3 at the front, and there is no need to multiply it inside the middle. Okay, so you can ask me that about that later if you're like, why don't you have to do that? But you'll recall that from Math 15. So on the left side, then we have negative 3y plus 6 is equal to x plus 4. And then I need to move everything over to this side. So I'll just add 3y to both sides. And I will subtract 6. So then I'm going to have 0 is equal to x plus 3y minus 2. So we're just going to check that this is indeed in general form. So general form means everything's on one side. Yes, we did that. There's a 0 here. General form means that there are no fractions as coefficients. And we've killed off our fractions, so that's good. And general form also means that the coefficient of x has to be positive. We can't have a negative x in the front. So this is okay as well, and this is general form. So in slope point form, we are going to substitute in x1 and y1. So y minus y1, so we're going to put plus 8 is equal to 3/4 x minus 0. Or if you want, you can just delete the 0 and have it like this. And that would also be acceptable. To convert to general form, I'm going to choose to use this version of the equation just because it's a bit cleaner, easier for me to deal with. So for general form, I'm going to try and kill my fractions first. So I will multiply both sides by 4, this side and this side. So then on the left side, I'm going to have 4y plus 32 is equal to 3x. And then I will move everything over to the right side. So 3x minus 4y minus 32 is your equation in general form. In this example, they gave us a point, and they did not give us a slope, but they gave us a clue to be able to figure out the slope. If something is parallel to this line, that means it has the same slope as this line. And what is the slope of this line? Well, it doesn't have 1, say half the kids. Well, yeah, it does. It's just that this has a coefficient of 1, so the slope is 1. So our slope is also 1. And you have to just make sure that when you put in x1 and y1, you're using a plus sign because of the double negative. And then you have this. If you did not write the 1, I would forgive you. So in this case, again, they've given you a point and they have not given you a slope, but they have given you a clue to allow you to figure out the slope. So it says that it's perpendicular to this line. So here's the slope of this line. We do not want the slope of the black line. We want our perpendicular slope. So the slope we are interested in is a negative reciprocal. Negative 1/4 is a perpendicular slope. So that is the slope we are going to use for m. And then we will use x1 is here, so that becomes a plus because of the double negative. And then y minus 0. If you did not write the 0, I would forgive you, but you just have to recognize that it's the same thing. So it has given us a diagram with some lines, and it's asking us to determine the equations in slope point form. So we're just going to do A to start. The most important thing to figure out for slope A is what is the slope. So if we do a rise over run and we make sure that we understand this is a negative slope, this is from previous lessons, then you'll know that the slope of A is -1 and the slope of B is +1/2. Doesn't matter which 2 points you measure from. Those are the slopes of the lines. We'll talk about C later. So in the first example, if you were to start to label convenient points on slope A, you're going to get a lot of convenient points. So how do you know which of these points you should use for the equation in slope point form? So I'm just going to do it with the first one first, y minus y1, so y minus 1, I'll use this point right here, is equal to -1 because that's the slope, and then x minus x1, so +5. Or maybe I could write it with the second point that they give us, -4, 0. So I would go y minus 0, but the slope is still -1, and x plus 4. As a matter of fact, both of these are correct. How is it possible for a single line to have two different equations, though? It is possible because if you simplify both of these equations out to y equals mx plus b or general form, they will simplify out to the exact same thing because they are the exact same line. So when we are writing equations in slope point form, those equations are not unique. There are an infinite number of correct equations for slope point form on any given line. But if you simplify them all out, they come to the same thing. So for example, with B, slope B, you could say y minus 2, if I choose this point here, is equal to 1/2 x minus 0. Or you could say y minus 3 is equal to 1/2 x minus 2. And those would both be correct for slope point form. For line C, because the slope is undefined, we cannot find a value for m, and we cannot write it in slope point form. That is impossible. However, you can write an equation for this line. So to write the equation for line C, as a reminder of what this means, if you start to label the coordinates here, this is 6, 1, this is 6, 2, this is like 6, 5, 6, -2. No matter what point you pick on this line, the x value is 6. And that's why the equation of that line is x equals 6. Just as a reminder, if I had a horizontal line, like so, then the y's are going to equal 6. So if you had a line D over here and I wanted the equation of this one is y equals 6. So when you have horizontal or vertical lines, you get these special forms of equations where it's just like y is equal to something or x is equal to something. And you just have to remember which one is the vertical version and which one's the horizontal version.